Hi, in this video we are going to demonstrate how to deploy a MySQL database with Kubernetes cluster and what restrictions Rafi can place for different users to access the DB running in it. What is MySQL database? It's an open source database management system that is used to manage and store data in various applications and websites. What are the prerequisites for this particular exercise? Well, the user should have an org admin privilege role to create other users with different privileges such as namespace admin, etc. We should have one managed Rafi cluster with EBS CSI driver installed, and the user should have kubectl access to the cluster via ZTK. So let's test whether we have all the prerequisites or not. We already have deployed a Kubernetes cluster. This should work on all the type of clusters, but for this exercise we are doing it on Amazon EKS. We are able to access the ZTK. Let's test the pods. We already have EBS CSI driver installed, so we match all the prerequisites. Let's move forward. Next, we will first create a namespace. In the later part of the exercise, this namespace access will be provided to a developer having namespace admin role, which will be used to demonstrate the restrictions Rafi put on users having those roles. So let's go ahead and create that namespace. For that, we'll click on infrastructure namespace. We'll just copy the namespace name. We'll go to the namespace, click on new namespace, provide the name, select wizard, click on save. We'll go to placement, select the cluster which we want to associate this namespace with. Click on go save and go to publish, and click on publish. Once done, you can re-verify that on the cluster, going to the kubectl and typing get namespace, you can now see the developer namespace as part of the cluster. Now we are going to configure our cluster and deploy the MySQL database. For that, we'll first create the secret, then the PVC, which is used to ensure that the MySQL data persists even if the pod restarts. Next, we are also going to create deployment and services for MySQL using the secret and the PVCs created earlier. Next, we are also going to define a role for MySQL database. This will be created in the developer's namespace which we created earlier. Similarly, we'll also create the service account for the developer and bind the role created earlier to the service account. This too will be created in the developer's namespace which was created earlier. Lastly, we will create a test pod to check and attempt the access to MySQL database. How we are going to do it? We'll create add-ons for all these things and tie all these add-ons to create a blueprint which will then be deployed to the clusters. Let's go ahead and first create the secret. In this scenario, you need to type the password which you want to deploy on your cluster as a secret. In this scenario, I'm just giving my own password. You can go ahead and give your secret based on your choice. We'll access, click on kubectl and we'll paste the command. Our secret is created now. Next, we are going to create the add-ons for all these configurations. How we are going to do it? We'll go to add-ons in the infrastructure, click on new add-on, give a name to the add-on, sorry, type Kate YAML, and you have to select the default namespace, click on create, click on new version, give a version name, upload the file for the configurations which was shown earlier. Click on save changes. Add-on is created. Similarly, we will create the add-ons of each of these configurations. To save time, I've already configured all those add-ons onto the Rafi system. Next, we are going to create a blueprint out of it. Click on new blueprint, give it a new name, click on save, give a version number, select minimum or minimal as the default blueprint, scroll down, come to the add-on section, configure add-on, and select all those add-ons which were created. In this scenario, we have MySQL service, MySQL PVC, MySQL deployment, developer SA, developer role, developer test pod, and we should have, I think we have covered all the add-ons required. Click on save changes. Again, click on save changes. Now your blueprint is ready to be deployed on the cluster. In order to do that, we'll go to infrastructure, cluster, select your cluster's gear icon, click on update blueprint, and select the blueprint which was created. Click on save and publish. Give it a few seconds and this should deploy. Our blueprint is now successfully deployed on the clusters. Let's check the pods running now. We can see two new pods running on the cluster, one in default namespace and the second one is the developer's namespace. Let's run an exec command on the pod running on the default namespace to access our MySQL DB. Next, we'll need to run mysql -u uroot -p to get into the MySQL DB. You need to give the same password which you gave earlier while creating the secret. Now you have logged into MySQL database which is running successfully on your cluster. Let's create few data and tables in order to test the persistence of data if the pod running in default namespace gets deleted. In order to do that, let's run show schema. We'll see all the default schema available. We'll create a database. We'll again run the show schema command to check whether the cluster database is created or not. Now it is successfully created. Now we have changed it to the cluster database and we will create a table. We will insert few data into that table created, and now we will verify whether the data is present on that table or not. Yes, we have successfully created a row within the table. We'll exit the database. We'll close this connection and we'll go ahead and delete the pod through which we entered and created the data. You now see a new pod is regenerated in the default namespace. Let's check whether the data has persisted in our MySQL DB or not. This is the new pod which was created in the default namespace. Let's run the same exec command, this time on this particular pod. Same MySQL uroot-p command, and you have to give the password which you gave while creating the secret. Sorry. As you can see, the database is present. Let's log into that particular database. The data which we created earlier before deleting the pod is still present in the new pod, hence the data has persisted. Now that we have seen that the data within MySQL database persists, let's check the other pod which was created in the developer's namespace. What we have done is we have created a new user with namespace admin role. We have provided the user the access to only the developer's namespace. Let's see what restrictions are put in place by Rafe. In order to create a user with namespace admin, you can refer our document, the Rafe document, which clearly states the steps to create a specific user with specific role. Here we have created that user with the namespace admin role, and we have given the access to only the developer's namespace. Let's check if the other pod is still running. Yes, the other pod is still running. We will take the help of the service which was created earlier to access to this. Let's log out and log in through the new user which was created. As you can see, we have very limited access to the cluster already. Let's go and check what resource we can see. We can only see the resources which are present in the developer's namespace. Let's do a kubectl to it and run few test commands. As you can see, we cannot run most of the default command. Let's see if we can get the pod which is running in developer's namespace. As you can see, we can only access the resources in a specific namespace. Now let's see and run an exec command on this particular pod to see whether we are able to access the database directly or not. Well, I still can't run the exec command as well. Let's go ahead and try it with the developer's namespace. We are able to log in only when we use the -n developer namespace filter. In order to log into the DB, since it is running in a different namespace, we need to tell that we want to log into the default namespace database. So we'll use a different command in this scenario. Where we are specifically stating that which database in which namespace we are trying to access. Now we are able to access the cluster, the MySQL database. Let's see if the data persists. As you can see, the database exists. Let's check whether we have data within that particular database. can see the table also present. Let's see whether we have data in that table. We have the same data which we created by logging in as the org admin into the database. Now Rafe has placed several restrictions in order to access the database. You can still access the database in a particular namespace with the same level of access which you had previously as the admin. If you still want to restrict your access within the database, for example, you want to create a read-only user accessing that particular namespace, that can be done with the help of your database administrator. Rafe can help you in restricting various access to your database running internally or externally. That's all for this video. Thank you for watching. Bye-bye.